Let's see how we are on time. We are almost exactly on time. So I will go through the batch system and talk about Slurm, which is the open source job scheduler, which is used at Kebnekaise and at most of the centers in Sweden, if not all of them. And then when I've done that, we will have a lunch break, and then we will get to do some simple examples and exercises with jobs running on Kebnekaise. So let's go ahead here and repeat. Only run long parallel large jobs through the batch system, for instance, through Open On Demand. Kebnekaise runs Slurm, the open source job scheduler, which provides three key functions. It keeps track of available system resources. It enforces local system resource usage and job scheduling policies. And it manages a job queue, making sure that the jobs start according to the policies. So in order to run a batch job, you first need to create and submit a Slurm submit file. This can also be called batch submit file, batch script, or job script if you're looking at it online. You can also start jobs by just giving all the command in a line on the command line, but it's better to do a batch script simply because then you have it and you can see what you did exactly and make changes to it instead of trying to remember what it was you wrote a week ago or whatever. Another way of doing a batch job is to run an interactive session through Open On Demand, because that starts by allocating time on a compute node, and that we will look at as well. There is guides and documentation in HPC20's batch system documentation. As I said, it's often best to use a job script. And if you submit a job, the system will return a job ID, which you also get with sq-me. And job script is in what I have written here. The name you give your job script and job ID is the job ID for your job that Slurm assigns to it. Username is your username. So you submit a job with sbatch and the job script. Let's see what we had here. We could try and submit hello.sh. I will talk more about the script itself in a moment, but I'm just going to show you what happens. So I say sbatch and then hello.sh. And then it says submitted batch job 3505, etc. This is the job ID. And you can also get a list of the job that's running with SQ minus your username, or for short, SQ minus me. Now, nothing was running here because it was running pretty fast. So I'm just going to submit this batch job a few more times. And then you can see here that you get a list of your jobs. Here are the job IDs. The partition is running in. It's telling me it's on the Zen 4 CPUs. This is the name of the job. If you don't give the job a name, it will use the name of the job script. What user is it? It's me. What state does it have? It's running. It could also be completing CG or pending PD or a number of other states. Time is how long it has run. They only just started, so it hasn't run any time yet. but it is allocated and running. This tells me how many nodes, or rather cores, it's using. And this, when it starts running, it will give you a list of nodes that is running on. So aside from this, you can also add sq minus minus me minus start minus minus start, because then it will also add the start time that it expects at this time. But the thing is, it can change. But this is a calculated, assumed start time. But things can happen. I mean, other jobs can be submitted where they have higher priority, or maybe another job ended faster than was expected, and then your job started earlier. But it is a guess to the start time. You can also check more on a specific job with S control show job ID. Let's try do that. It works while the job is pending and running and a short time afterwards. So here is some information about the job with this job ID. You can see who submitted it. And there's also what priority it had. It has completed. We knew this. And it tells me how long did it run. It was short. It ran 2 seconds. It also tells me I had said it was allowed to run 1 minute. And this tells me when did I submit it? When did it start? And when did it end? What partition did it run in? What nodes did it run on? How many CPUs? And all these things here. Much information, including what is the path and name of the submit script and the working directory and things like this. This is all very useful, actually, because if something goes wrong with your job, then this can help you to see if it, for instance, is consistently on one node it happens. And it can also help you find where your scripts are and where your error and output files went. If you want to delete your job, perhaps you submitted a number of jobs and you have realized you made an error and you don't want it to finish running, because why should it use your allocation when it's not going to give you useful output? So you can end it with scancel and the job ID, or all of your jobs scancel minus your username. It's also possible to request an interactive allocation with salloc. You probably don't want to do that because it's not going to be a real interactive work, because you need to preface everything you do with srun, or it will run on the login node because you stay on the login node. So you will probably want to run on open on demand if you want an interactive job. This command here will give you a more detailed info about the job. The output is very wide. So you will type it to less minus capital S, which will make it scroll sideways with the left and arrow keys. That will give some output that includes how much memory was used and so on. There is also the friendlier output, which is graphical output with info of the job. There is job usage, with minus between here, job usage, a space, and then the job ID. That will give you a URL to the job that ran, where you can see information like how much memory did it use, how was the AI, and things like that. Oh, output, input, OI, IO, sorry. And there's, of course, more information to be found in the man files. But I think I'm just going to start a slightly longer job. Let's try this. The reason for that is that in order to get some output to this graphical info, you need a job that's long enough to be more than maybe a few minutes at least. But job usage and then the job ID. That gives you a URL you can copy. Still running. We put this here. And it doesn't have much data yet because it hasn't run long enough. But when it has run a bit more, you will get some nice graphs that show how much memory it uses and what the I/O is, what is the CPU utilization, and things like this. And you can use it to see if there's some sort of problem with the job. Maybe it's using up more memory than is available, and you need to up the memory you need and things like this. So that is possible. This was what I just did. As you can see here, if I say ls, the output goes to either the output that your program creates or to slurm minus the job id.out. You can also change that so it goes to two separate files. And you can do that with this here, sbatch minus minus error equals job and or output inside your job script. And it's good to add %j because that contains the job ID. And that means that each new incarnation of the job that runs will not overwrite the previous one because it has a new name. So, and if you want to look what's inside these Slurm scripts, then you can use any of the editors. And maybe if it's short, just cat, which just outputs the content to the screen. I'm just going to copy this here, paste, and see what's in it. This one just had hello world because it was this short program it was doing. So it is time to look at job scripts. And job submission files can either be very simple, where you specify most on the command line, or you can have lots of different Slurm directives. You can name the script as you want, and it doesn't have to be called anything specific. It also doesn't need a suffix. You can put what you want. It's just called something that makes it easy for you to find and remember. Maybe something that stands out in your directory. What is common to use is to put .sh or .sbatch because then you can easily find it when you scroll through your files, but you don't have to. So, a simple serial job script. First, there's this here that tells it that it needs to run in a specific type of shell under Linux, Bash, and that's because that is the only one that's compatible completely with the batch system. It doesn't matter why and what it does, but just put that there to begin with. Then you need a name of the account you're running in. That's mandatory. And this is a Slurm directive, so you preface it with hashtag sbatch, has to be capital letters. And then -a tells it that what comes now is the account. And then you put your account ID here. For this, it's HPC2N 2025 -158. Then we request resources. In this case, it's for a serial job. As default, tasks per core is 1. So if I ask for 1 core, 1 task, it's the same. I can change it with -c. Then I ask for some runtime for my job. It's hours, minutes, and seconds. It's at most 168 hours. So that's a week. Okay, I'm asking for 15 minutes. Then I clear the environment from any previously loaded modules with module purge. I don't want the output from module purge to go into my output file. So I throw that to dev null. And this says take errors and output from this command, throw it to dev null. It's just a place to get rid of it. Then I load any modules that I need. In this case, I need FOSS2023B. And now I can run my job or the serial program that I had. I do that. So this is the simplest serial job script. And I just talked about this. If it's an MPI program, it's very simple, very similar. But here you want more tasks. In this case, 8. Otherwise, much is the same. Of course, you need to load a module that has MPI. And then you should use srun to run it. That's for MPI jobs, but not for serial jobs. And of course, the other option is maybe your program does it itself, then it should also not be there. But mostly MPI programs have srun in front of it. And I am assuming you already did this, but if not, then go ahead and make sure you have the exercises. In order to run these various scripts without doing anything else, then you need to compile a small number of programs, namely hello.c, MPI hello, MPI greeting, MPI hi. And when you have done that, you can run these bash scripts directly if you name scripts the same as I do. So I am going to go ahead and compile all those. Let's see. I already compiled hello and MPI hello. Now I'm going to do MPI greeting and MPI hi. And I also did the OMP hello. Okay. And it was MPI programs. And let's see. Now you can submit these ones here. And these scripts I am going to talk more about after lunch under simple examples. Let's see how. Let's take 5 minutes and then, or maybe just 3 minutes, and try and use SBatch to submit one of these here. You can pick any of those, they should all run. And then check with SQ minus minus me if it's running, pending, or completing. If it runs too fast, then submit several of it. But yeah, to try and do that, and you probably need to submit some of the longer ones in order for it to run long enough for you to actually cancel it. But you can try these exercises. Maybe I should actually just finish this section. Let's see how much is left. No, I think the best thing is that let's take an early lunch and then you do the exercises first. So there's 9 minutes until lunch. Try and do as many of these exercises as you can. And after you have done that, then you can take lunch and then we will start again at 1 o'clock.